odd planet. It's not just that many features of Earth have to be just right to support life. What is most amazing is that many complex processes must continue to operate in delicate balance for our planet to continue to be a zone of life. What if? It's easy to imagine a few simple changes that would make life on Earth impossible or very difficult. For instance, Earth spins as it circles the sun. This gives us day and night. Earth also is tilted 23.5 degrees from upright as it spins. It is the spin and the tilt that gives us our seasons. What if Earth were not tilted? The poles would be much colder and the new equator much hotter. Without the tilt, only half as much land could be lived on, and many kinds of plants and animals would die. Earth is not a large planet, yet its size is exact and essential. If it were too small, Earth's weakened gravity could not hold either air or water. Thinner air would provide no protection from the 20,000 or so meteorites that rush toward Earth daily. With thinner air, temperatures would drop and life could not exist. If Earth were twice as large, the atmosphere would be pulled closer to its surface. Everything would weigh 8 times as much, and that weight could crush most living things. If Earth were twice as far from the sun, it would receive only 1/4 the amount of heat we now receive. Living things would freeze during winters twice as long as now. If Earth were half as far from the sun, its surface would get 4 times the heat and would become a burning desert. If Earth did not have a large moon revolving around it, there would be no tides in the sea. The oceans would grow stagnant, their waters unable to provide the oxygen that fish need to live. Any of these changes would make life on Earth impossible. Our world had to be just the way it is, placed just where it is in the solar system, to be a zone of life. Earth isn't going to lose her moon or suddenly jump closer to the sun. But it isn't just the big things that affect life on Earth. The existence of life also depends on many active processes that take place right now. For instance, what if there were no rivers in the sea? Rivers in the sea. The Gulf Stream is one of the most famous of the rivers in the sea. Benjamin Franklin in 1786 told of a conversation with the captain of a whaling ship. In it, he learned of a current of faster waters that flows like a great river of the Atlantic Ocean. Franklin even made a chart to mark its course. Today, we know that that river, the Gulf Stream, carries 5,000 times as much water as the Mississippi and 25 times the water carried in all Earth's rivers combined. It is warmer and bluer than the surrounding sea, and the warmth of its swiftly moving current keeps Great Britain from having frigid, unbearable winters. What is the Gulf Stream? Modern satellites have helped us realize that it is part of a gyre, that is a 13,000-mile wheel of water circling in the Atlantic Ocean. The Pacific has a gyre too. It touches Japan and then swings outward to bring warm waters to the coast of California. The Pacific gyre is called the Black Current because its waters are such a deep blue. What causes these gyres? North of the equator, they are caused by strong, steady winds blowing from northeast to southwest at low latitudes, and similar but opposite steady winds blowing eastward at higher latitudes. It is friction from the winds and the spinning of Earth that sets the waters moving and maintains each current's flow. Each current in the sea sets the waters below it flowing too. Loops of water break off and form slow-moving whirlpools called eddies. Deep currents, as well as the surface flow, are caused by nothing more powerful than the winds, blowing steadily on the surface of the sea. But is this important? Yes. One science book explains, if the ocean's depths were truly stagnant, as was long believed, they would fill with death and decay, for the remains of all that lives in the sea fall toward the bottom and a slow and steady rain. Without deep currents to stir things up, noxious fumes would slowly gather near the floor and kill all the bottom-dwelling creatures. Slowly, the Earth's own body heat would warm this foul black water until it was hotter than the water on the surface. Then, as oceanographer Geert Van Andel has written, the unstable ocean would eventually turn over and vent the whole mess to the surface, with catastrophic effects on the fauna and flora, animals and plants, of the surface waters, and perhaps poisoning the atmosphere. The circulation of water on our planet, with the constant motion of those rivers and currents in the sea, is one of the processes on which life on our Earth depends. What could go wrong? As we noted, Earth is unlikely to jump away from the Sun. But what concerns some scientists are little changes in the processes that are necessary to enable Earth to support life. In fact, what puzzles many scientists is the fact that changes in some of those processes haven't happened. When so many things could go wrong, thoughtful scientists have been forced to wonder, why haven't they? The greenhouse effect? One thing that worries some scientists is that the Earth might experience a greenhouse effect. Today, there are only about 400 parts per million of carbon dioxide gas in the atmosphere. Carbon dioxide is made of 1 part carbon and 2 parts oxygen. It is the important gas that plants breathe, using the carbon and giving off the oxygen that human beings and animals breathe. Humans and animals, in turn, breathe oxygen and exhale carbon dioxide. Carbon dioxide is also given off by burning oil, coal, and wood. Today, there are more and more people on Earth, and many of the forests that used to cover our planet are being cut down. And today we burn more and more fuels. This means that the amount of carbon dioxide in the atmosphere is increasing. The problem is that carbon dioxide gas in the atmosphere tends to keep in heat rather than to let it escape into space. With much more carbon dioxide in the atmosphere, Earth might possibly become a giant greenhouse, and Earth's temperature would rise, causing global warming. A rise in temperature of just 3½ degrees could make a huge difference. The greatest effect would be at the poles. Ice at the North and South poles would begin to melt. The Antarctic ice cap could break apart, and if it did, the oceans could suddenly rise dozens of feet. Miami, New York, and other coastal cities would be drowned. What's more, the new temperatures would likely change the pattern in which air flows around our world. The Midwestern United States, where our grain is produced, would lose rainfall, and its dried soil would be blown away as dust by the winds. But will the Earth become a greenhouse? Scientists on both sides of the issue argue over whether human-caused global warming is a reality or a hoax. And the temperature rise has been much slower than predicted 20 years ago. In the past, Earth has always seemed able to adjust, although no one really knows how. If a warmer Earth led to increased evaporation and more clouds, and they blocked out just 1% more of the sun's energy than now, that could cancel the effects of the extra carbon dioxide. It seems God provided Earth with a natural check and balance system to reduce extreme climate changes. The terrible termites. The global warming threat isn't just caused by humans. There are other gases in Earth's atmosphere, as well as carbon dioxide, that have similar effects. The fifth most abundant is methane gas. Methane gas, too, is a greenhouse-producing gas. Where does methane come from? One source is termites, which produce methane when they digest wood. But how could tiny termites be a danger to our planet? A scientist named Pat Zimmerman was in Guatemala to measure the gas rising from volcanoes. One day, out of curiosity, he put a Teflon bag around a termite nest and watched in surprise as the bag filled with methane gas. Zimmerman began to study termites all over the world. He found methane gas pouring out of termite mounds everywhere. And wherever he found people cutting down Earth's tropical forest, he found termite populations exploding. Still, how could that be a problem for the whole Earth? We realized it could be a problem when we learned that every year people cut away forest areas about the size of the state of Connecticut. In the tropics, there are possibly 1,500 pounds of termites for every human being on Earth. Zimmerman has figured that these termites alone are adding 100 million tons of methane gas to our atmosphere each year, and this amount increases yearly as more forests are cut down. There are other sources of methane gas as well, but it is stunning to think that something as tiny as the termite has the potential of dangerously changing conditions on our entire planet. Holes in the air. Another thing about our atmosphere that worries scientists is the ozone layer. Ozone is an unusual form of oxygen, the most common element in Earth's system. It takes outside energy to produce ozone. The electrical discharge of lightning transforms some of the pure oxygen in the air into ozone. But most ozone is formed high above us in Earth's upper atmosphere. There, ozone absorbs 97 to 99% of the sun's high-frequency ultraviolet light, protecting life on the surface from harmful radiation. It is the formation of ozone in the upper atmosphere, and ozone's higher concentration there, that protects life from some of our sun's most harmful rays. What worries scientists is the discovery that since 1979, the ozone layer of the atmosphere between 18 and 20 miles up seem to be growing thinner at a rate of about 4% a decade. A recent discovery showed that there are actually seasonal holes in the ozone layer over the Earth's poles. In 2003, scientists announced that a ban on some of the gases in aerosol cans, spray cans of deodorants, paints, insecticides, etc., has reduced the size of the ozone hole at the poles. But it may take generations before the ozone level fully recovers. Actually, no one knows just why the ozone layer seems to be thinning. No one even knows how thick it is supposed to be. All that scientists know now is that the formation of the ozone layer is one of those processes that has to operate for life to continue on our planet. A major mystery. While ozone is a recently discovered wonder, oxygen itself is a major mystery. Oxygen is one of the most reactive of all elements. That is, it is quick to combine chemically with other elements. 2 parts of hydrogen combined with 1 of oxygen produces water. If we mix these 2 gases, they do not remain separate. They quickly and actively bond to each other. Oxygen quickly bonds to many other elements as well. Actually, about 46% of the mass of Earth's crust is oxygen, combined with metallic and non-metallic rock. As we saw in Chapter 2, on a dead world, chemical reactions have stopped, as life-supporting gases have bonded with other substances. Such worlds are in equilibrium. No fresh chemical reactions are taking place. On a dead Earth, the atmosphere would be about 99% carbon dioxide. Mars and Venus are dead worlds right now. Their atmospheres are in chemical equilibrium and contain no free oxygen. On Earth, the air is 21% free oxygen. Chemical reactions that maintain just the right amount of oxygen in our atmosphere keep on taking place, and keep carbon dioxide at about 0.03%. For life to exist, this balance must have been maintained from the beginning. Without oxygen, animals could not breathe. Some scientists think that if oxygen levels were greater than 25% instead of 21%, the whole world would actually burst into flames. However, in order to explain the large fossil insects found in sedimentary rocks, geologists have postulated past oxygen levels of up to 35%. We just don't know enough about the past to really know exact levels. But we can be certain that God provided oxygen as part of His created original world. One scientist inventor has written a book on Earth's life-supporting systems. In the book, Gaia, A New Look at Life on Earth, James Lovelock argues that Earth acts like a living thing itself, constantly adjusting to keep every condition right for the living things on it. Lovelock does not know how Earth adjusts, but he is sure it must. If the support processes were not kept in constant balance somehow, life would not exist here now. Lovelock argues that too much has gone right to credit luck, and too much that could have gone wrong hasn't. Lovelock says that there is about as much chance for this to just happen as there is for a blindfolded person to drive safely through rush hour traffic. But Lovelock does not turn to God to explain the wonders of our living earth, even though he has no other explanation to offer. Yet the more that Lovelock and others discover about Earth, the clearer it becomes to us that our planet was designed and did not just happen. Everything testifies to the fact that God made the earth and the heavens. Genesis 2 verse 4. The fundamental law of nature. In the last chapter we noted that those who study our universe have discovered and described laws that operate in nature. One of the most fundamental is the second law of thermodynamics. The second law, often called the law of entropy, says that any physical system left to itself will decay. Instead of being highly organized like our Earth systems, everything will break down. Chemical processes will reach equilibrium, that dead state found on Mars and Venus. But the processes that operate on Earth remain highly organized. These processes are not breaking down. The atmosphere, the oceans, the relationship between plants and animals, all seem designed to take energy from the sun and use it in an organized way. Instead of breaking down, these processes even seem to adjust constantly to maintain that delicate and perfect balance without which all life would end. The Russian scientist Dr. Boris P. Dosenko was once head of the nuclear physics department at the Institute of Physics in Kyiv, USSR, now Kyiv, Ukraine. Although he was taught not to believe in God, he began to think about what it means for Earth to be the way it is, in spite of the second law. Later he wrote, "As I thought about all of that, it suddenly dawned on me that there must be a very powerful organizing force counteracting this disorganizing tendency within nature, keeping the universe controlled and in order. This force must not be material, otherwise it too would become disordered. I concluded that this power must be both omnipotent, all-powerful, and omniscient, all-wise and all-knowing. There must be a God, one God, controlling everything." Later, in Canada for further studies, Dr. Dosenko found a Bible. Reading the Bible, this Russian scientist met the God whom he had become sure must exist. Now a Christian, Boris Dosenko stayed in Canada and taught physics at several schools and universities. Not every person who studies science will reach the same conclusion as this Russian who was brought up as an atheist. But the evidence is there. Everything around us, including the delicate balance in nature that makes life on Earth possible, makes it clear. Our world didn't just happen. Our world was designed, and even today, Earth is guided and protected by God.